Do everyone knows about ISS, International Space Station? Does not matter, yes or no. Must watch this video, as those who know will get to know more and those who did not, they will get to know it. Welcome to TechieSpod, where you will get all the information on interesting topics and blogs on it to read. If you are not subscribed yet, then you are missing out something. So, here we go. ISS. International Space Station, ISS, is a space station in low Earth orbit. The ISS program is a multinational initiative between 5 participating space agencies from the world: NASA, United States, Roscosmos, Russia, JAXA, Japan, ESA, Europe, and CSA Canada. The ownership and use of the space station is established by intergovernmental treaties and agreements between these 5 partners to work together in field of space. The ISS serves as a microgravity and provides space environment research laboratory in which scientific experiments are conducted in astrobiology, astronomy, meteorology, physics, and other fields of research. The station is suited for testing the spacecraft systems and equipment required for possible future long-duration missions to the Moon, Mars, and other researches in space. It is the largest artificial object in space and the largest satellite in low Earth orbit, regularly visible to the naked eye from Earth's surface. It maintains an orbit with an average altitude of 400 kilometers (250 mi) by means of reboost maneuvers using the engines of the Zvezda service module or visiting spacecraft. The ISS circles the Earth in roughly 93 minutes, completing 15.5 orbits per day, making it very dominant place for space study. The station is divided into 2 sections: the Russian orbital segment, ROS, operated by Russia, and the United States orbital segment, USOS, where the Crew Dragon on 31 May 2020 docked, which is shared by many nations. Roscosmos has endorsed the continued operation of ISS through 2024, but had previously proposed using elements of the Russian segment to construct a new Russian space station called OPSEK. As of December 2018, the station is expected to operate until 2030. Now it's time to know about construction of ISS. The first comes manufacturing of components. As we know, the International Space Station is a multinational group initiative project. The components for in-orbit assembly were manufactured in various countries around the world. Beginning in the mid-1990s, the U.S. components Destiny, Unity, the Integrated Truss Structure, and the solar arrays were fabricated at the Marshall Space Flight Center and the Mashhad Assembly Facility. The Russian modules, including Zarya and Zvezda, were manufactured at the Khrunichev State Research and Production Space Center in Moscow. The European Space Agency Columbus module was manufactured at the EADS Astrium Space Transportation Facilities in Bremen, Germany, along with many other contractors throughout Europe. The other ESA-built modules, Harmony, Tranquility, the Leonardo MPLM, and the Cupola, were initially manufactured at the Thales Alenia Space Factory located at the Can Mandalay Space Center. The structural steel hulls of the modules were transported by aircraft to the Kennedy Space Center SSPF for launch processing. The Japanese experiment module Kibo was fabricated in various technology manufacturing facilities in Japan, at the JAXA Tsukuba Space Center, and the Institute of Space and Astronautical Science. The Kibo module was transported by ship and flown by aircraft to the KSC Space Station Processing Facility. The mobile servicing system, consisting of the Canadarm2 and the Dextray grapple fixture, was manufactured at various factories in Canada, such as the David, Florida Laboratory, and the United States, under contract by the Canadian Space Agency. The mobile base system, a connecting framework for Canadarm2 mounted on rails, was built by Northrop Grumman. These are certain example of components, but many are already in process and there is large way ahead. Second comes assembling. The assembly of the International Space Station, a major milestone in space architecture, began in November 1998. Russian modules launched and docked with help of robot, with the exception of Rassvet. All other modules were delivered by the Space Shuttle, which required installation by ISS and shuttle crew members using the Canadarm2, SSRMS, and extravehicular activities, AVAs. As of 5 June 2011, they had added 159 components during more than 1,000 hours of EVA. 127 of these spacewalks originated from the station, and the remaining 32 were launched from the airlocks of docked space shuttles. The beta angle of the station had to be considered at all times during construction. The first module of the ISS, Zarya, was launched on 20 November 1998 on an autonomous Russian Proton rocket. It provided propulsion, attitude control, communications, electrical power, but lacked long-term life support functions and better communications. 2 weeks later, a passive NASA module Unity was launched aboard Space Shuttle Flight STS-88 and attached to Zarya by astronauts during EVAs. This module has 2 pressurized mating adapters, PMAs, one connects permanently to Zarya, the other allowed the Space Shuttle to dock to the space station. At that time, the Russian station Mir was still inhabited, and the ISS remained uncrewed for 2 years. On 12 July 2000, Zvezda was launched into orbit. Pre-programmed commands on board deployed its solar arrays and communications antenna. It then became the passive target for a rendezvous with Zarya and Unity. It maintained a station-keeping orbit while the Zarya Unity vehicle performed the rendezvous and docking via ground control and the Russian automated rendezvous and docking system. Zarya's computer transferred control of the station to Zvezda's computer soon after docking. Zvezda added sleeping quarters, a toilet, kitchen, CO2 scrubbers, dehumidifier, oxygen generators, exercise equipment, plus data, voice and television communications with mission control. This enabled permanent habitation of the station. How much did it cost for constructing ISS? The ISS has been described as the most expensive single item ever constructed because it needed to be assembled in space. As of 2010, the total cost was $150 billion United States dollars. This includes NASA's budget of $58.7 billion for the station from 1985 to 2015, Russia's $12 billion, Europe's $5 billion, Japan's $5 billion, Canada's $2 billion, and the cost of 36 shuttle flights to build the station, estimated at $1.4 billion each, or $50.4 billion in total. Benefits of ISS when its construction get completed. 1. Research. The ISS provides a platform to conduct scientific research, with power, data, cooling, and crew available to support experiments. Small uncrewed spacecraft can also provide platforms for experiments, especially those involving zero gravity and exposure to space, but space stations offer a long-term environment where studies can be performed potentially for decades. Combined with ready access by human researchers, this can enhance researches as it provides ideal environment, and the cost of creating it in Earth is much more with less accuracy. 2. Exploration. The ISS provides a location in the relative safety of low Earth orbit to test spacecraft systems that will be required for long-duration missions to the Moon and Mars. This provides experience in operations, maintenance as well as repair and replacement activities on orbit, which will be essential skills in operating spacecraft farther from Earth. Mission risks can be reduced and the capabilities of interplanetary spacecraft advanced. And much more that even we cannot imagine, as space has enormous reach and possibilities. So, guys, this all about this topic. Don't forget to like, share and subscribe. That's all for this video. I hope you all like it. Please follow us on Instagram, Facebook and Twitter. The links for the following are given in description. Thank you.